Stop paying for noise. Prune your RAG context and slash token waste by 40% instantly. If your RAG feels like a black box bleeding API tokens, it's because you haven't moved beyond the retrieval step. You're dumping everything into the LLM, and that includes all the noise. Naive chunking is the industry standard starting point. But when you scale, that to standard becomes a financial liability. You are paying for context the LLM will never use. Professional-grade RAG systems don't just retrieve, they curate. They intervene in the information journey to ensure every token spent drives value. This brings us to the two critical stages of surgical pruning: query decomposition and context re-ranking. Query decomposition is about turning a monolithic question into a sequence of targeted subqueries. Instead of what happened with the Q3 acquisition, you ask 3 specific, actionable questions. This allows the retrieval step to be surgical. It doesn't blindly search for the answer, it searches for the specific pieces of evidence needed to build that answer. The first stage is the initial vector search. We generate candidate chunks based on the decomposed query, but we don't commit to them yet. The critical shift happens when we move from initial candidate retrieval to the re-ranking stage. This is where you dramatically improve signal-to-noise ratio. Instead of relying solely on the initial embedding similarity score, which is often broad, we use a smaller, specialized cross-encoder model to rescore the top candidates against the original query. This cross-encoder reads the asterisk relationship asterisk between the query and the chunk, not just their individual vectors. It determines true relevance, the contextual fit. The result? The initial top K candidates might have been rank 1, but after re-ranking, they drop to rank 8. The truly relevant context finally rises to the top. We are now feeding the LLM not just irrelevant chunks, but asterisk highly validated asterisk, contextually perfect snippets. Let's look at how this translates into code. Here is a simplified example of the pipeline structure in Python. Beat 1, the initial vector search. We use the decomposed query to pull a larger set of candidates, say, 50 chunks, to ensure we don't miss the needle. These candidates are the net. They cast a wide drag net to ensure comprehensive coverage, accepting potential noise for maximum recall. Beat 2, the re-ranker. This is where the magic happens. We pass those 50 chunks and the original query to a dedicated cross-encoder. The cross-encoder acts as a highly specialized critic. It doesn't just look at vector distance, it assesses semantic alignment and narrative flow between the query and each chunk. It elevates the truly valuable pieces and ruthlessly demotes the superficially similar but contextually irrelevant ones. The output of the re-ranker is a pristine shortlist, often just 3 to 5 chunks. This is the surgical incision into your data. Only these few chunks are now passed to the main LLM context window. You have successfully replaced a noisy torrent with a concentrated, potent dose of truth. This reduction, from 50 candidates down to 5 critical chunks, is where the 40% token savings comes from. It compounds across high-volume use cases. When you combine this with query decomposition, you solve the needle in a haystack problem by turning it into 3 small, manageable searches. The combination is synergy. Decompose to narrow the search space, re-rank to optimize the retrieved context. This transition from brute force retrieval to intelligent information curation is the difference between a hobby project and a profitable, enterprise-grade AI service. Start small. Identify your biggest context leakages. Implement the re-ranker first, and watch your costs stabilize while your answer quality skyrockets. If you found this breakdown valuable, hit subscribe. We dive deeper into advanced scaling strategies next week.